Prior to discussing the announcement, it is essential to comprehend what particle accelerators are. The LHC, the Large Hadron Collider, which CERN operates, is a 17-mile-long ring of superconducting magnets. It is the largest and most powerful particle accelerator ever built, symbolizing the highest level of human achievement in science. In fact, it is powerful enough to recreate the conditions of the universe's birth. Could this apparatus be used to unlock the secrets of the universe? The key might lie within. Established in 1954, CERN is one of the world's most reputable research institutions, with 23 member nations and thousands of scientists. It is a hub of innovation and collaboration. The LHC is CERN's flagship project, but it is only one component of a vast network of experiments and accelerators. Picture a racetrack, not for horses or cars, but for subatomic particles. The LHC competes with time and space itself. It accelerates protons to nearly the speed of light, causing them to collide in a controlled course that mimics the intensity of the Big Bang. The temperatures caused by these collisions are more than 1,000,000 times hotter than the core of the sun. Protons are guided on their journey by thousands of intricate magnets. These magnets are kept at temperatures colder than outer space, maintained by sophisticated cooling systems. Inside the LHC, beams collide at 4 points along the ring, each location corresponding to one of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each detector serves a distinct purpose, exploring different aspects of particle physics. Combined, they act like enormous cameras, capturing images of the collisions. Scientists then sift through the debris, searching for evidence of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues about the fundamental building blocks of reality. By studying the microcosm, we gain insight into the macrocosm. However, with each answer comes a new question, and with every discovery, new challenges emerge. The LHC is not simply a scientific instrument. It is a testament to human ingenuity and curiosity. It exemplifies our relentless pursuit of knowledge and the deep desire to understand the fundamental forces that govern our universe. But as we push the boundaries, we must also consider the ethical and existential questions that arise. What are the dangers of probing the unknown? Could our search for understanding unintentionally unleash forces we cannot control? In the very halls of CERN, where human comprehension is constantly being tested, a new revelation has emerged, one that even the most seasoned scientists hadn't anticipated. Brian Cox, a prominent physicist, former CERN researcher, and a respected voice in particle physics, recently made an announcement that both fascinated and unnerved the scientific community. Cox stated, with haunting clarity, that the purpose of the LHC is to recreate a miniature version of the Big Bang. Yes, that's correct, a miniature Big Bang, the very event that gave birth to our universe. He went on to enumerate the profound implications of this goal, highlighting the LHC's remarkable potential to unlock secrets of the Higgs boson and dark matter, a mysterious substance believed to make up a significant portion of the cosmos. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a thrilling possibility, but also a perilous one. The miniature Big Bang is not just theoretical, it is a reality observed at the LHC. The temperatures, pressures, and raw energies involved mirror those at the dawn of time, during the birth of existence itself. But with such power comes immense responsibility, and a troubling question looms. What happens if something goes wrong? In fact, something did go terribly wrong once. Anatoly Bugorsky, a Russian physicist, experienced a horrifying accident in 1978 while working on the U-70 synchrotron at the Institute for High Energy Physics. Due to a mistake, his head accidentally crossed the path of a proton beam, a beam so forceful and beyond comprehension that it passed through his skull, entered the back of his head, and exited through his nose. He described seeing a flash, brighter than 1,000 suns, yet felt no pain. The beam burned through bone and tissue, leaving a trail of destruction. Incredibly, Bugorsky remained conscious and even attempted to walk to the clinic for treatment. The aftermath was both horrifying and awe-inspiring. Localized tissue died. He lost hearing in one ear and suffered partial facial paralysis. Yet, his intellect remained intact, and he continued working as a scientist. This incident was not just a personal tragedy, but a cautionary tale that highlights the immense power and danger of particle accelerators. The potential for unintended consequences when manipulating the very fabric of space and time is real. These are not science fiction concerns. They are genuine fears expressed by some in the scientific community. One of the most troubling and intriguing possibilities associated with experiments at the LHC is the creation of a miniature black hole. A black hole is a region of space-time with such intense gravity that nothing, not even light, can escape. These cosmic vacuum cleaners, capable of devouring stars, are mysterious entities lurking in the shadows of our universe. The idea that the LHC might create such an object, even on a microscopic scale, is shocking to both the public and professionals alike. Could such a black hole expand, spiraling out of control and consuming the Earth? CERN scientists assure us that any black holes produced would be unstable and would evaporate almost instantly. Still, the mere possibility has sparked fierce debate, widespread anxiety, and profound awe. To understand how the LHC could theoretically create a black hole, we must delve into the foundations of particle physics. When protons collide at near light speed, the energy released is immense, so intense that it can distort the fabric of space itself. Imagine a trampoline being tightly stretched, and then a heavy object placed at its center. The surface depresses, perhaps so severely that nearby objects are pulled in. That's a simplified metaphor for what might occur in the quantum realm. In LHC physics, the universe behaves in strange and mind-bending ways. Some scientists even believe that hidden extra dimensions might exist, dimensions that LHC collisions could tap into, creating gravitational funnels that lead to mysterious, microscopic black holes. This idea has even drawn the attention of respected figures like the late Stephen Hawking. In his writings, Hawking warned of a theoretical scenario where the Higgs boson could become unstable at very high energy levels. Such a fluctuation, he suggested, could result in a catastrophic event known as vacuum decay, an existential threat, not just to Earth, but to the entire universe. Sir Martin Rees, a renowned British cosmologist and physicist, echoed these concerns. In his book about the future of humanity, he examined the potential risks posed by CERN's experiments. Pertaining to particle accelerator experiments, such as those carried out at CERN, his words were more than just words of caution. They were infused with an existential tinge of terror. He described the worst-case scenario. A disastrous experiment might create a state known as vacuum instability. This instability could, in theory, cause a phase change that would spread throughout the entire fabric of space-time, resulting in a cosmic calamity with the potential to engulf the entire universe. Reza's worries were unfounded, restricted to theoretical reflections, and assigned only a minor probability of catastrophic results. However, he argued that even a minuscule chance ought to make us pause. The stakes are unimaginably high, and the margin for error is very small. Scientists at CERN have calculated the odds, conducted simulations, and investigated the theories that support the collider's safety. In fact, Brian Cox himself, an advocate for the LHC, recognized the significance of responsible investigation. There are many worries and fears concerning the LHC's operations. He stressed that there are extensive safety measures in place, strict procedures and checks that ensure the collider is operated with the highest level of care. Cox reassured the public that the energies involved are well within the range of what Earth naturally encounters, and the likelihood of developing a stable black hole is extremely low. Even if one were created, scientists predict it would be so fragile and small that it would disappear in a flurry of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation, a fleeting glimpse of cosmic wonder into the depths then vanished. Some have gone one step further and speculated that the LHC's experiments might open the door to another dimension or universe. Despite the fact that the scientific community remains skeptical, this notion has captured the imagination of many. It fascinates, scares, and has even evolved into modern folklore. What lies beyond what we see and do? Could we accidentally activate forces or entities we are unable to comprehend? The concept of opening a door to hell has even generated sensational headlines across various media platforms, contributing to the blaze of uncertainty. How exactly did this idea originate? What does it mean in the context of scientific investigation? Parallel dimensions are not a new concept in physics. String theory, one of the most promising candidates for a theory of everything, suggests that additional dimensions beyond the usual 3 of space and 1 of time may exist. These additional dimensions may be compressed or hidden from view, but could theoretically be accessed or revealed under extreme conditions. Imagine the LHC as a key to the cosmos, unlocking sealed doors that have remained shut since the beginning of time. When protons collide at unimaginable energies, they achieve on Earth what was once thought possible only in the early universe, potentially wreaking havoc on the fabric of space-time and possibly revealing undiscovered dimensions. The scientific community, however, remains doubtful of such sensational claims. Yet the very concept of a particle accelerator unlocking the universe's mysteries has increased public concern about the potential dangers and consequences of such experiments. In the end, the LHC remains a potent symbol of human ambition and curiosity. It is a testament to our progress in understanding the universe, as well as a reminder of the risks that come with this understanding. The universe may be vast, but the more we learn about it, the more we realize how little we actually comprehend. The pursuit of knowledge is one of humanity's greatest achievements, but there are also many unknowns and dangers. Only time will reveal whether we are prepared for what we may discover next. The Large Hadron Collider is not only a marvel of modern science and technology, but it also opens the door to questions that re-examine the very foundations of our understanding of the universe. The machine itself is an engineering masterpiece, an enormous underground ring filled with some of the most precise and advanced equipment ever constructed. It brings together a global network of researchers and scientists united in their quest to answer some of the most fundamental questions about the cosmos. But as scientists test the limits of human understanding, they also face significant obstacles, both ethical and theoretical. The LHC focuses primarily on the endeavor to understand the forces that govern the universe. For centuries, researchers have tried to unravel the complexities of gravity, electromagnetism, and the strong and weak nuclear forces. The LHC offers an unprecedented opportunity to study these forces under extreme conditions. Particles colliding at such high energies mimic the conditions that existed just moments after the Big Bang. At that time, the universe was a steaming, dense soup of particles. This allows researchers to investigate the behavior of energy and matter in ways once thought impossible. Despite the LHC's potential for groundbreaking discoveries, such as the detection of supersymmetric particles or dark matter, there are significant concerns regarding the limits of experimental science. Some physicists have grown increasingly aware that the experiments carried out at the LHC might be unlocking more than just insights into the cosmos. It's possible they are revealing new forces or dangers that humanity is not yet ready to face. One of the most fascinating and unsettling ideas in this regard is the concept of vacuum decay. According to this theory, under certain conditions, the energy produced by LHC collisions might cause a catastrophic shift in the fabric of space itself, triggering a series of events that could alter the very nature of reality. While the probability of such an event is extremely low, its potential consequences are so severe that some believe it warrants careful consideration. If vacuum decay were to occur, it could lead to the collapse of the universe as we know it, destroying all matter and energy. Despite the speculative nature of these concerns, the LHC remains a focal point for scientific inquiry. The excitement about potential discoveries often outweighs the voices of caution. At CERN, thousands of scientists work tirelessly, driven by a deep desire to understand the fundamental laws that govern existence. Yet due to the frontier nature of their work, the ethical implications of such powerful experiments continue to provoke debate. Another concern is the possibility of unintentionally creating phenomena we do not yet understand. The LHC has already demonstrated the ability to produce exotic particles, such as the Higgs boson, that had previously only been theorized. However, this capacity to generate new forms of matter also raises the question of whether we might inadvertently create particles or entities that pose unforeseen risks.